Hello guys and welcome to another video. So on this one we'll be looking at our revision for paper 1 physical sciences. So without wasting any time, let's get into it. So this is the question that we're gonna first look at. It is our MCQ, multiple choice. Okay, so this is how it goes. So here it says that we have various options and we have to choose the correct one. Now they say here an object is positively charged if it has, if they say it is positively charged, obviously positive charges have to do with protons, right? So that's what we'll be looking at. So here they say an object is positively charged if it has more electrons than protons. That would be wrong. Electrons than neutrons. That would be wrong. If it has more electrons, yeah, it's a different story. Okay, if it has electrons than protons, it means it would be negatively charged. Protons than electrons, this one definitely is going to be our option. D says protons than neutrons. No, okay, that one won't work. Okay, so the correct option here has to be D because they're saying positively charged. If it has more protons than electrons, then it definitely is positively charged. That's our answer. C. 1.2 says a car is traveling at a speed of 30 meters per second on a straight road. What would be the speed of the car in kilometers per hour? When you convert, guys, from kilometers per hour to, or rather, when you convert from meters per second to kilometers per hour, you simply have to multiply by 3.6. If you are converting from kilometers per hour to meters per second, you divide by 3.6. So here we are going to take this 30 and multiply it with 3.6, and the answer we get, I believe, is going to be C. So our answer is going to be 108 kilometers per hour. Okay, that's how we'll tackle this question. Let's move on to the next one now. Okay, the next one says the unit in which the rate of flow of charge is measured is called the rate of flow of charge. Okay, how do we write that formula, guys? We write it, it starts here. We have this formula: Q is equal to I don't know if it's I. Yes, it should be I multiplied by delta T. So if I'm dividing by delta T on both sides, then it means I'm gonna have I, and I just go back a bit here. It means I'm going to have I is equal to Q divided by delta T. So this is current. Current is defined as the rate of flow of charge. Delta T is the rate. So we are saying the rate of flow of charge. Q is the charge. So current, guys, is measured in what unit? Current is measured in the unit of amperes, okay, which normally is a big capital letter A. That is our answer for that question. Move on to the next one. The gradient of a velocity versus time graph is equivalent to what? Let's draw our velocity versus time graph. This will be our y, this will be our x. This side we have our time, and this side will have our velocity. Okay, on the y-axis we have our velocity, on the time on the x-axis we have our time, and the velocity versus time graph normally would be something like that, and this is a straight line, right? And the straight line here would give me a gradient like that. My gradient would be what? My gradient would be A is equal to delta V divided by delta T. And what does it represent? It represents current, or I mean acceleration. I don't know why I'm saying current. So the correct option there, guys, is going to be A. Okay, that is going to be our option. On a velocity versus time graph, we have acceleration as our gradient. Then we go to 1.5. For 1.5, they're saying an object is released from the top of a frictionless inclined plane AB as shown below. Which one of the following statements regarding the total mechanical energy of an object is correct? This is what you know, guys. We know that if this is our top and this is our bottom, then the total mechanical energy here should be equal to the total mechanical energy there. So the mechanical energy before, which is at the top, will be equal to the mechanical energy after, which is at the bottom. So the correct option we want is that option that says this part here, the mechanical energy here is equal to the one that's here. And this one says this one is greater than that one. That won't work. This one, the mechanical energy at the top is equal to the one at the bottom. That's not correct. C though is going to be correct. Do you see that it says the mechanical energy at the top, which is at point A, is equal to the mechanical energy at B, which is at the bottom. So C is going to be our answer there. Okay. And then we go to 1.6. It says we have two identical light bulbs which are connected in parallel as shown in the circuit diagram below. Okay, voltmeters V1 and V2 are connected across each light bulb. Then they say which one of the following voltmeter readings is correct. Guys, we know that in a parallel circuit, the voltage is the same across all the resistors that are connected in parallel. So the voltage here would be equal to the voltage here. Whether the resistors are equal or not, the voltage will always be the same by virtue of this connection being parallel. Okay, so the option we want is one that says the voltage in V1 is equal to the voltage in V2, which is going to be A. That is the only option that we want. We don't even have to think too much about that. So A will be your answer there. Then we go to 1.7. 1.7 says we have four identical balloons, each carrying a charge, and they are suspended from a ceiling as shown in the diagram below. Then they say balloon B is negatively charged. So this one is negatively charged. And then they say which combination is correct regarding the charges on the balloons. So this is what we are going to look at, guys. We already know that B is negatively charged, but we see that B and A are attracting each other. And that means A is supposed to be positive. Then when we come to this side, we see that C and D are repelling because this one is separated from this one. So it means C may be negative as well as D, or they may both be positive. We don't know which option is gonna work, but when we look for our options here, we are gonna check which ones, especially with reference to A, is gonna work for us. Okay, we just want these ones C and D to have the same charges so that they can repel, and then these ones will have opposite charges. So let's check. Sphere A is negative according to option A. Well, sphere A cannot be negative because if it were negative, it means it would repel B. So A is not our option. Sphere B is positive. We already know that sphere B is negatively charged, right? We already know that. So option Option B definitely won't be our answer. Let's look at C. C says sphere A is negatively charged. Sphere A, guys, cannot be negatively charged. Otherwise, it would repel sphere B. So C will not be our option. And then D says sphere A is positively charged. Yes, that's correct. We can see that. Then here, remember, we said that we may have C and D being both positive or negative. But here, they are saying, okay, I don't know what's going on here. Oh, guys, I left out option C. I don't know. Why did I leave option C? I mean B. I didn't look at option B properly. So for option B, we see that sphere A according to option B is positive, so that's correct. Okay, then when you check sphere C and D will be both positive, so B is going to be our option, guys. B has to be our option because it means that C and D are both positive instead of negative, because remember we said they might either be both negative or both positive. So the option that we have here is that they are both positive. Thus, we are gonna go with option B. Okay. D won't work because it says C and D are oppositely charged, which is not correct. Okay. Now let's go to 1.8. 1.8 says two cyclists are cycling in opposite directions along the line, along the sideline of a rectangular field. It is observed that they covered the same distance over a time interval of 3 seconds. Which one of the following physical quantities is the same regarding the cyclist over the interval 3 seconds? This one, guys, talks about average speed, and average speed, as we know, it is the distance, uh, or rather the total path length covered per unit time. That is the definition of average speed. So they told us that they covered this distance, the same distance, over a time interval of what, 3 seconds. So that means we are talking about average speed. That is going to be our option there. Okay, the other ones are not going to work. Now let's look at 1.9. 1.9 says we have a red light of frequency f and a wavelength of, or rather, and the wavelength shines on an object. Yeah, we have frequency f and a wavelength lambda which shines on an object. The red light is then replaced by light of a higher frequency. How do the frequency and the wavelength of light shining on the object now compare to that of the red light? So guys, here they are telling us that this red light is replaced with a light that has a higher frequency. What does that mean, guys? It means that, or rather, higher energy. Yes, higher energy. That's what I meant to say. So the light that is replacing the red light has a higher energy. And this is what you know about energy. We know that energy is directly proportional to frequency. So if I have an increasing energy, it means I should also have an increasing frequency. So the options I'm going to look at are option A, because it tells me that I'm going to have a greater frequency. As my energy increases, I should have a greater frequency. So I will also look at C to see which one of the two are going to be my options. B and D are not going to be my options, so they are out. Okay, now another thing we are going to check is what wavelength we are going to have, and for that we will look at the relationship between frequency and the wavelength. So we know that if we have an increasing energy, we also have an increasing frequency. But what happens when we have increasing frequency to the wavelength? If I increase my frequency, it means I should decrease my wavelength. So if I'm gonna have more of my frequency, then I will have less of my wavelength. Okay, so that's what you're gonna look at. Are we having a great frequency and a less wavelength? Okay, because if I'm gonna have more frequency, I should have less wavelength. So if I look at option A, it says yes, I will have a greater frequency, but I have the same wavelength. So this won't be correct. Now let's look at C. C says I'm gonna have a greater frequency, an increasing frequency, right? But when I have an increasing frequency, I should have a less wavelength. So here it says less than. So that means our option here is going to be C. Okay. Then we move on to the last question. This question says that study the following wave patterns, then which combination is the correct representation of the wave patterns with the same pitch? Okay, pitch, remember guys, has a relationship with frequency. Here we don't really see much about frequency, but what I'm noticing here is that um, if I'm gonna check wavelength 1, it's similar to wavelength 4, or rather the wave pattern 1 is similar to wave pattern 4 because they start at the same position. And then, do you see that, guys? We can say they are in phase, if you will. Okay, they are both here and then they go down at the same time, they go up at the same time, and so forth. So the option I'm just gonna go with here will be C. Yeah, based on the fact that they are in phase, if you will. Yes, that's my answer. Okay, and then I'm done with this question, guys. I'll see you on the next video with another question. This was us taking our multiple choice. Okay, see you on the next one. Bye bye. Don't forget to like and subscribe if you have not already.